we have in Department of Science and Technology, there would be half a dozen different committees on chemistry alone, right? So it'll be organic, inorganic, physical, green, red, biochemistry, and so on, right? And now people argue that we should have not half a dozen, but 1 dozen committees, right? Because you see, because if I have this more committee, if I know all these people in the committee room when I walk in, I feel very good. I know all these guys, they'll give me money, right? So now, see, being interdisciplinary is very hard. Nobody really likes it. Well, okay, if it makes you some money, then okay, well, I would be interdisciplinary or whatever you want me to be. But you see, to be committed to that knowledge which is beyond my boundary is something very special. And it requires that we unburden ourselves from who we are and how we have been trained. And this is the hardest thing to do, truly, truly. So now I tell my students, or whoever would listen, I tell the young people, actually there are no old people, there are younger people. So I tell younger people, I say, look, there are no such thing as mechanical engineering, nothing, right? There are 4 or 5 different things in science. And they are more major pillars of science than the undergrad education and degrees that we receive in any of this. To my mind, I call them 4 M's of doing science. So this is mechanics, the first M, which is understanding of what it is. So it could be quantum mechanics, classical mechanics, electromagnetism, what have you, even understanding biological structure, function. Understanding is what I call mechanics. The second M of doing science are materials, because anything you want to do, well, you need material to build something on, and artificial cell, everything is a good example of that. So materials, mechanics. Third one is what you would call devices, machines, M for machine, systems, basically something which is integrated using mechanics and materials. And the fourth M we often ignore is manufacturing. And most respected scientists just don't want to say anything about manufacturing. They say, this is beneath my dignity to talk about manufacturing, to talk about economics, to talk about innovation, to talk about startups, or any of that, right? But you see, essentially we recognize, because again I said for young people, we recognize that innovation is what completes the circle of knowledge. Now this may appear to be a little bit strange. We are all in knowledge business. But we are into knowledge business of one kind, one direction. What is that knowledge business we are in? This is what I call invention or discovery science, which is we need money, we need resources to produce knowledge. Now, if some of this knowledge is converted back to new opportunities, that is called innovation. So invention goes from resource to knowledge. Innovation goes in the opposite direction, from knowledge to resource to generating new resources. This is about generating knowledge, but also consuming knowledge. So unless we had a good balance between generation of knowledge and consumption of knowledge, the knowledge itself is not sustainable. We should talk about the sustainability of everything, which means let's produce knowledge, let's consume knowledge, produce resources, make more knowledge, and everybody lives happily ever after. So this is what I want to convey to young people. Don't think that what we are doing in university is the end of knowledge. The challenge actually comes in using that knowledge to produce new opportunities, which is what we call innovation. Innovation is not to be confused with something creative, something smart, something great discovery. That's not the meaning of innovation. Innovation is orthogonal to invention. It is opposite of invention. And this ought to be understood very clearly as part of our knowledge ecosystem. In fact, if I go talk to people who are graduating in some convocation, I tell them, look, innovation is something you do when you are young. Innovation, startups, for example, you do that, and very relevant for nanomedicine, because now nanomedicine has to get into that phase, which is the translational phase, which is to produce opportunities based on it. So anyway, I say, look, innovation and startup is something that happens when you are young. In fact, it happens when you are single, because after you are married, you cannot even change a TV channel. And so there's a wisdom taught to me by my wife. Yeah, so what she said, I'm just reproducing it. So this is, but there is a counterpoint to every story. So I say, look, be single, be young, do it. But there are other days, there are other cases when there are a lot of people come to my office, they complain from day to night. All day long they complain. So of course, complaints are good. They are justified. If they are justified complaints, they are good. But sometimes I have to tell them, look, what I think you need is go get a spouse, because not everything can be blamed on the government, right? So sometimes it's a context-sensitive advice. Sometimes I say remain single. Sometimes I say go get married, right? So anyway, whatever solves my problem is the advice I give. Now, see, other great things which are happening today in science and technology and will happen more in the future is we shift our attention from being tool-centric to problem-centric, which I think we all understand, which is saying the same thing as saying, don't be wedded to chemistry, physics, material science, engineering, medicine, whatever. Don't be exclusively wedded to these things, because to solve a problem, the problem is not that of organic chemistry. Hardly any problem in this world is of organic chemistry. What I mean is not organic chemistry is an example. It is not a problem of a single domain of knowledge. So therefore, to solve a problem, we have to be problem-centric, not, well, I'm a chemist, so I can only do this, right? So thing I talked about, one of the challenges that the future is going to face, which is both a challenge and an opportunity. If you have to list one, actually you have to list two. What do you think these are? Okay, two challenges of the future for every scientist, for every technologist, for everybody who's a thinking man, okay, no matter what we do. The first challenge is the rise of intelligent machines, what we call cyber physical systems. And we launched a new program in the country worth about 4,000 crores. So the DST, Department of Science and Technology, would set up these very special hubs which are related to cyber physical systems. And what does it mean? It means something, a machine, which has perception, which has action, which has computing, which has communication, which has decision making. So now you have to ask yourself the question, this is where the huge opportunities are. So whether you're talking about nanomedicine, autonomous systems. Now look at the fact that India does not have so many doctors, right? How many doctors do we have per capita? Would be very low. So, and we are not going to produce them overnight, whether it's radiologists, whether it is this, that, right? Now if I train an artificial intelligence engine with data, with big data, then a whole lot of these diagnostics actually could be done remotely, and it could be done by a machine, and that's of course going to happen because that's round the corner. Just to remind you, there are three kinds of tasks that people do. As scientists, as people, we do manual things, we do cognitive tasks, and we do creative tasks. The machines are better in anything manual, repetitive. Machines are better in cognitive, because cognitive means arrive at a decision based on a whole lot of data that I have. No single mind is capable of making a great decision based on large amount of data. There's a problem of pattern recognition. Pattern recognition, machine can do it much better, much faster, real-time data and decisions, decision making. The third is the creative. What do we understand? We have to be more creative, right? Because when there is a stress with the machines, you have to be more creative as humans. What does it mean to be creative? nobody has given me very good understanding of actually what it means to be creative. Creative is, like when I'm feeling particularly pleased with myself, at the end of the day, having done something, I say, oh, this is really creative. But let's not forget that, just last year, this machine called Alpha Zero, it beat in chess the other machine which had the complete wisdom of all the grandmasters and all the great games of chess which have ever been played. Now, of course, machine beat the world champion long time ago in the 90s. I'm not talking about that. This is something special because this new machine, Alpha Zero, it was not trained by any human. So this is basically, look, here is this game of chess. It is governed by these rules. It has these pieces. Now you go learn chess, right? Within 4 hours, it can actually beat the accumulated wisdom of chess over the centuries, right? What does it mean? And the moves that this machine puts out is what you would call creative, because they are not the same moves that you have seen before in these books which are written by grandmasters of chess. So this is what it means to be creative. So this is the last strength of humans. So, well, slowly you lose ground. So what does it mean? Now you have to ask the question about what does it mean to be human, right? So in other words, you have to find the strength in which a machine cannot outperform a human, right? So no matter what we do, if we do nanomedicine, if we do anything else, we have to find that niche. We have to focus on that niche that 30 years down the road, as me as a human, I would be competitive against a machine. That is the challenge of the future. The second, I said there are two challenges if I have to put out here. The second challenge, what do I think it is? Look, we have lived in the best of times. All of us, my generation, a generation before me, and the one that comes now. We have lived in the best of time because we lived with the technology. But no constraints. What are the constraints? The next generation and 100 years from now will have to face are the constraints of resources, constraints of environment, constraints of climate, right? So this is what we call sustainable, we talk about sustainable development goals. No matter what kind of scientist I am, I must find a way to address sustainability with development. And there's a whole lot of challenge and opportunity there because it's about science, it's about technology, it's about new skills, it's about new education, it's about new business, right? Whole lot of business even in climate change. So this is what we call the technology solves one problem, but it must produce another. And so therefore we remain in business all the time. But going back to the sustainability issue. Sustainability issue, look, first of all, let's understand, there is no such thing as sustainable development. I mean, it's very hard to say that, especially for me, okay? But the point is this, it's an oxymoron. There is no indefinite sustainability with the present model of development. We have a thing called, the modern society has an operating system. That operating system is called money. That operating system is called growth economics, which is one particular kind of economics. But anyway, having been wedded to that idea of growth economics, there is no such thing as sustainable development. There may be, while you say, okay, by end of the century, my goal is to have 3 degrees Celsius increase. But remember, Earth is not here for 1 century. Hopefully it is there for more than 5 more centuries. Or I don't know, at least few more centuries. So if we are going to have targets which say, look, 2 degree increase, 3 degree increase, which is acceptable, right? Then over 5 centuries certainly would boil over. But anyway, it's a, each generation has to worry about itself. And I say, look, what do I care? Okay, what happens after 100 years or what have you? But these are true challenges of technology, is to have sustainability with development. And we need these the technologies which are not just dhanda. Okay, so what I mean by dhanda, see, when we talked about innovation, there are three different ways of doing innovation. In fact, there are three different ways of doing any scientific thing or any scientific action. Dhanda is one of them. Dhanda is what we call the incremental changes. So I asked somebody, is saying, incremental changes, 2% better next year, 5% better next year. This is what is called dhanda. So I run into my friend on the street. I say, dhanda kaisa chal raha hai? He says, very good, chal raha hai. Okay, everything is good, stable. Stable change is called dhanda. Another thing which is unique in India, another way of doing business is what we call jugaad. Jugaad is another way of doing things, and some of it is in scientific domain. Jugaad is not a good way of solving problems, even though it would solve my problem for today by hook or by crook, but it is not an optimal solution. It is also not scalable, and it is not applicable to a wide variety of challenges in that domain. So let us not worry too much about jugaad. Jugaad, good, okay, somehow I can solve my problem today, but now worry about tomorrow. So jugaad, dhanda. What I am really emphasizing is the third way of doing things, which I call panga. So panga is the disruptive change. And so a whole lot of our science, 90%, 95% of it has to be incremental or dhanda. This is what we call filler material. This is what we tell our PhD students, please publish 5 papers, then you will graduate, right? So these are filler materials, these are incremental work, which is good for training, but it's not going to do anything great to this world. So therefore, we have to think disruptively, think creatively, and don't worry about offending people. So it's like this. I'm the first one to tell my students. I say, look, if an elderly man like me says something is possible, I am certainly